Let's solve some of these problems off of your solving polynomials worksheet. This is problem 8 and 13. Let's start off with problem number 8. Looking at this, it looks like a difference of squares, but I have this r to the 4th power here. So what I'm going to do is try to set it up the way I want it to. I want it to look like r squared and then just a number. So what I'm going to do is plug out or find the greatest common factor. Okay. This would be, I would say, I could pull out an r squared. The reason why I'm not pulling out anything else is because I want to keep these to be, I want these to be perfect squares. So I'm left with 4 r squared minus 64 equals 0. Okay. Now, the reason why I did this is because if I multiply here, if I distribute, I end up getting this. So r squared times 4r squared is 4r to the 4th, and r squared times negative 64 is negative 64r squared. So we're good there. Now, if we remember our equation for difference of squares, it's a squared minus b squared equals a plus b times a minus b. Okay, so essentially what I want to find out is this is my a squared, b squared. I need to find the square root so that I could just plug in. So let's find the square root of 4r squared. The square root would be 2r. The square root for b, which is 64, would be 8. Okay, so now plugging these numbers into here. My a would be 2r plus 8, 2r minus 8. Okay, I factored this section, but remember that there's an r squared being multiplied to all of this. Okay, so I'm going to rewrite this. I'm going to write an r squared here attached to here. Okay, don't be confused with this. Here, let me erase this part right here. Okay, so now that I have all of this equal to 0, I could set, by the multiplicative rule, I could set each one equal to 0 because they're all being multiplied to each other. So to solve this, I would say r squared equals 0. 2r plus 8 equals 0. And 2r minus 8 equals 0. So when I start solving for these, I find the square root here, and this ends up equaling r equals 0 because the square root of 0 is 0. So that's one of my answers. Now here I'm going to subtract 8 to both sides, okay, and then I'm going to divide by 2, okay. So this ends up being r equals negative 4, okay, because I have a negative 8 up there, then a 2r divided by 2. Negative 8 divided by 2 is negative 4. Do the same thing here, but in this case, I'm going to be adding the 8. So that's going to be the same thing as the previous one, but it's going to be a positive 4. So these would be my 3 answers for this equation. Now let's look at the next problem. Let's start off by combining like terms. Combining like terms, I have an r cubed. So I'm going to bring this over here. I'm going to leave that to 0. So I'm going to bring these over by adding a 4r cubed. 4r cubed. The reason why I add here is so that this becomes 0. Okay. And then here I end up with, I just have 6r cubed minus 4r cubed. That becomes a 2r cubed. I'm going to rewrite these down here. Actually, I'm going to bring that 9r squared over So let's do that. If I want to bring it over here to this r squared, I'm going to subtract 9r squared. Subtract 9r squared. Okay. This becomes 0. And this is 5r squared minus 9r squared. That would be negative 4r squared. We'll bring this one down, plus 2r equals, both of these ended up being 0. So now this looks better, but still not how I want it to look like. I want to get it down to my highest degree being a 2. And I see that all of these have something in common. I can, before I start trying to factor this, let's try to find the greatest common factor, okay? So my greatest common factor there would be 2r, okay? So I'm left with just an r there, because 2r times r equals 2r, r squared. So 2r times r squared gives me a 2r cubed minus negative 2r, and then 2r, so that's a plus 1 equals 0. Okay, so if I distribute this here to each one and multiply, I should get my original polynomial. Now I'm going to look at just this section right here. Okay, now I'm going to say, how can I factor this? Well, I can factor this 2 ways. I can do the perfect square trinomial, or I can just do the regular general trinomial factoring. Okay, so if I want to, let's just do the a times c version. So a would be 1 times c would be 1, so that's 1. So I'm gonna write a little 1 here. Now I have to find multiples that multiply to 1, which is the only ones are 1 and 1. And if I add those, I should get the middle term. Now, if I add these, do I get a negative 2r or negative 2? No. I would have to give both of these negatives. So a negative minus a negative gives me a negative 2. A negative times a negative gives me a positive 1. Okay? So these are the numbers I'm going to use. So rewriting this out, I have a 2r floating out here. Then I have r squared minus r, right? Or negative 1r, that works too. Negative r for this one, and then plus 1. What I'm doing there is just splitting up these two sections into these ones that I found out. Because negative r minus r gives me negative 2r. Okay? Then here I'm gonna group, and then I'm gonna find the greatest common factor here. I can bring out an r, so I have a 2r times the r that I'm pulling out here, r, okay? And I'm left with r minus 1, right? Because r times r gives me r squared, r times negative 1 gives me negative r. I'm gonna plug out a negative 1 here, and I'm left with a negative, r minus a 1 equals 0. Now, if I distribute this, I would also get that. So we have the same thing inside the parentheses, so we know that we're in the right track. So essentially, I'm gonna combine these two. So I'm gonna say 2r r minus 1, and then r minus 1 equals 0. Or essentially, I could just write this as 2r times r minus 1 squared. I just rewrote them out the same. So all of these are being multiplied, so I can set each one equal to 0. So 2r equals 0. I'm going to divide by 2, r equals 0. This is one of them. Okay, I'm running out of room here, so I'm going to erase some of this. And I'm going to write r minus 1 equals 0 plus 1 plus 1, r equals 1. Okay. I do the same thing for the other one, so my two answers would be 0 and 1. Hopefully this helps, and continue working on your homework and solving these polynomials. Thank you.